In this video, we are going to be having some fun with acid and base indicators. Our learning goal is very simple. We are going to use various pH indicators to determine the approximate pH of a variety of solutions. Remember, Table M shows the common acid-base indicators that you may be expected to be able to use to determine the pH of a solution. We are going to be looking at some of these indicators in lab today. Now, I'm going to be performing a lot of the work on the lab bench for you all. You're going to be watching as I go through and use some pH indicator with various substances. So I just wanted to talk a moment about the safety precautions I will be taking as I do this lab. During the lab, I am wearing a lab apron to protect my skin and my clothing. I'm wearing goggles to protect my eyes. My hair is pulled back in a ponytail to make sure that none of my hair can get into any of the solutions that I'm using. And I'm also wearing gloves as I handle some of the indicator solutions and some of the acids and bases solutions that I'm testing. These are important safety precautions to take, particularly since a lot of the SDS materials data sheets for the various solutions and indicators that I was using suggested that I use skin protection, eye protection, and protection for my clothing. Let's get to it.
We're actually going to start with an indicator that is not on your reference table. You'll notice that your reference table contains the indicators methyl orange, Thymol Blue, Phenothalene, litmus, crystal green, and Thymol Blue. A mixture of those different indicators is found in universal indicator, giving universal indicator a wider range than the other indicators. We are going to test the pH of vinegar, baking soda solution, tap water, hand soap, lemon lime seltzer, lye, which is a form of potassium hydroxide often used for cleaning, and we're going to compare them to each other using 1 drop of universal indicator that's already been added to each of the test tubes here. So currently the test tubes only have tap water and universal indicator in them. I'm going to go ahead and add approximately 1 milliliter of each substance to each test tube. So that was vinegar. See, the vinegar has turned a nice color. We're going to do baking soda next. I'm going to rearrange these substances based on their pH once we're done. There's baking soda. Give it a moment to look for some change. For tap water, I'm just going to add a little bit of additional tap water because each test tube already contains tap water, but as a control, let's make sure we're adding some more. So there's tap water. Hand soap solution. So this is some hand soap with a little bit of water mixed in to make it a little bit less viscous. You can see a gradient forming as the hand soap solution makes its way down the test tube. I'll let it mix itself a little bit more. Do lemon lime seltzer, a favorite flavor of mine. I like seltzer as a soda to use because it is clear. And finally, we will look at our example with lye, which is often used as a drain cleaner. It's a very dangerous substance, which is one of the reasons why I am using so much safety here. Now, I am going to take a look at the universal indicator range here and think about how I might want to line up my substances. So I've got red, that was my vinegar. Baking soda is more blue, so I want to end up with it over here. I want to move my more orange and yellow further down on the pH scale. So let's say, it looks to me like lemon lime seltzer is closer to orange, hand soap is closer to yellow green. So I'm going to make sure I've got baking soda. I'm going to put lemon lime seltzer where baking soda was, so that saying that seems to be the second lowest pH based on its color. I can move tap water for a moment so that I can move hand soap over. And now I'll go tap water, baking soda, and lye.
So that's universal indicator. It's by far the prettiest, in my opinion, of the indicators because you get the full spectrum of colors because it is mixed in with other indicators. But you'll notice if you look at table N, universal indicator is not there. The indicators that are listed on table M work on a much narrower range than universal indicator. That's why universal indicator is called universal. We are going to look at methyl orange indicator with the same exact substances and think about what that indicator tells us about the pH of those substances. So methyl orange says that it changes from red to yellow when the pH range is between 3.1 and 4.4. That means anything with a lower pH than 3.1 should look red. Anything with a higher pH than 4.4 should look yellow. I'm starting off, same way I did before, with a series of test tubes with just tap water in them. The tap water has a pH, we can tell from the universal indicator, of around 7, which is higher than 4.4. So I am looking at a bunch of yellow solutions. I'm going to slowly, one by one, add each of my solutions from before to the tubes, and we'll see what color the indicator becomes. The vinegar immediately turns red, telling me that the pH of vinegar is below 3.1. Lemon lime seltzer and hand soap don't really seem to change, neither does tap water. Baking soda seems to stay the same, and so does lye. This indicates that vinegar has a pH of below 3.1, and lemon lime seltzer, while it does seem to be acidic, does not seem to have a pH that's that far below 4.4 because it did not start to turn red.
Let's look at Thymol Blue. According to table M, Thymol Blue should turn from yellow when the pH is below 6, to green when the pH is below 6 and 7.6, to blue when the pH is greater than 7.6, starting with just tap water in each of my test tubes. So it seems as though the tap water has a pH that's a little bit more than 7.6. I'm going to start with vinegar. Seems to have definitely lightened, and I am seeing a bit of a yellow tint to that light color. Lemon lime seltzer. A pale yellow, similar to vinegar. Hands up. You can actually see the color. It's paler at the top as the indicator comes into contact as the dish soap moves down. Tap water, so we'll just add some more tap water. Baking soda, and lye. So we can conclude from this spectrum that vinegar, which turned a pale yellow, has a pH of less than 6, and so does hand soap. And so does lemon lime seltzer, though they are closer to 6. That yellow color is taking longer to spread. Tap water seems to be more on the blue side, closer to 7, 7.6. And then baking soda is a little bit darker than water. Lye is the darkest, clearly has a pH of higher than 7.6. Let's continue through table M. The next indicator that we're going to look at is a harder one to pronounce. It's called Phenothalene. There's a lot of silent letters in it. Phenothalene is on table M. It goes from colorless to pink when the pH is between 8 and 9. So if the pH is less than 8, our solution should be colorless. Once it gets to be between 8 and 9, at some point there, it will turn pink. We are going to do the same setup and the same substances that we've been doing. So our vinegar, lemon lime seltzer, hand soap, water, baking soda, and lye. Vinegar has stayed clear. Seltzer stays clear. Hand soap stays clear. Tap water stays clear. Baking soda. I see a pink color for baking soda. And finally our lye. So the only test tubes that changed color were baking soda and lye. Baking soda a much paler pink than lye. This tells me that tap water, hand soap, lemon lime seltzer, and vinegar all have pHs of less than 8, that baking soda maybe somewhere between 8 and 9, and that lye is definitely a pH higher than 9. Let's look at Thymol Blue next. Thymol Blue changes from yellow to blue as the pH shifts from 8.0 to 9.6. pHs of less than 8.0 will look more yellow, then it will shift to green, and finally turn blue when the pH is higher than 9.6. Now, for our purposes, the tap water we know is close to neutral. So for our purposes, this is roughly a baseline for yellow for bromthymol blue. And we will add vinegar. Does seem to have gotten a bit more yellow, a bit more dramatically yellow. Lemon lime seltzer. Hand soap. More water. Baking soda. And lye.
So it looks like lye is the only substance that really showed a strong color change. Baking soda might have started to change a little bit, but not really. So lye has a pH of greater than 9.6, according to Thymol Blue indicator.
Acid and base chemistry, because of the pH indicators, can be some of the most visually interesting chemistry that you get to experience.
Let's check in once more on our learning goal. Hopefully you feel comfortable using indicators to determine the pH or the relative pH range of a series of solutions. I think seeing them visually is really, really helpful. Awesome job today.